Welcome to Section 9, Lesson 9. Partial fractions reverse the addition we did in Lesson 3. Take a single rational expression with a complicated denominator and split it into a sum of simpler rational expressions. The technique is essential in calculus and signal processing, but the algebra fits entirely in this section. When the denominator factors into distinct linear factors, the decomposition has one term per factor. Each term has a constant numerator over the corresponding linear factor. Find the constants by clearing the denominators and matching values. Repeated linear factors need one term per power. A factor x minus a appearing to the second power needs both a over x minus a and b over x minus a squared. The expansion grows by one term for each extra power. Irreducible quadratic factors get a linear numerator bx plus c over the quadratic. Quadratics that do not factor over the reals stay together. They are not split into complex conjugate factors. The corresponding numerator picks up a degree to match. Take 5 over x squared minus 1. The denominator factors as x minus 1 times x plus 1, two distinct linear factors. The decomposition has the form a over x minus 1 plus b over x plus 1. Find a and b. Clear the denominators by multiplying both sides by x squared minus 1. The equation becomes 5 equals a times x plus 1 plus b times x minus 1. This must hold for every x. Substitute strategic values. At x equals 1, the b term vanishes and we read a directly 5 equals 2a, so a equals 5 halves. At x equals negative 1, the a term vanishes and we read b directly 5 equals minus 2b, so b equals minus 5 halves. Write the decomposition. 5 over x squared minus 1 equals 5 halves over x minus 1 minus 5 halves over x plus 1. The graph below is the same curve as the original. The partial fraction form just expresses it as a difference of simpler fractions. Decompose 3x plus 5 over x plus 2 squared. The denominator is a repeated linear factor, x plus 2 squared, so the decomposition has two terms, a over x plus 2 plus b over x plus 2 squared. Set up the decomposition. Clear denominators by multiplying through by x plus 2 squared. The equation becomes 3x plus 5 equals a times x plus 2 plus b. Substitute x equals negative 2 to read b directly. 3 times negative 2 plus 5 equals negative 1, and the right side reduces to just b, so b equals negative 1. Match coefficients of x to find a3 equals a, so a equals 3. Write the decomposition. The expression equals 3 over x plus 2 minus 1 over x plus 2 squared. Each repeated power of the linear factor gets its own term, and the constants land directly from the substitute and match procedure. Decompose 2x plus 1 over x minus 1 times x squared plus 1. The denominator has a linear factor x minus 1 and an irreducible quadratic x squared plus 1. The decomposition has the form a over x minus 1 plus bx plus c over x squared plus 1. Set up the clear denominators. 2x plus 1 equals a times x squared plus 1 plus bx plus c times x minus 1. This identity must hold for every x. Substitute x equals 1 to find a directly. 2 times 1 plus 1 equals 3, and the right side becomes 2a, so a equals 3 halves. Then equate coefficients of x squared and x in the expanded form to find b, and cb equals minus 3 halves, c equals minus 1 half. Write the decomposition. 2x plus 1 over x minus 1 times x squared plus 1 equals 3 halves over x minus 1 plus the linear over irreducible quadratic. Irreducible quadratic factors keep their full form with a numerator that has both an x and a constant term. 3 takeaways for partial fractions. The form of the decomposition is decided by the form of the denominator's factorization. Distinct linear factors give one term per factor with a constant numerator. The number of unknown constants equals the number of distinct linear factors. Find them by substituting the corresponding x values that make each linear factor 0. Repeated linear factors need one term for each power from 1 up to the multiplicity. A factor x minus a appearing to the third power adds 3 terms, a over x minus a, b over x minus a squared, and c over x minus a cubed. Each constant is independent. Irreducible quadratic factors get a linear numerator bx plus c, never just a constant. The denominator stays as the irreducible quadratic. Do not factor it further over the reals. The constants b and c come from matching coefficients after clearing denominators.